Good to be here. Thank you all. Welcome to day 2. We're going to be talking about invocable actions. We're going to be getting fairly technical because this is a developer track event. It's a pleasure to be getting a full invocable actions focused session. I am Alex Edelstein. I'm a Vice President of Product Management on Flow. I do a lot of work with invocable actions. I'm joined with Ruben Roy, another product manager on the Flow team, and Eric Smith, who many of you know is one of the most expert Flow practitioners in the ecosystem. So, forward-looking statement, please make your purchase decisions based on commercially available product. I don't think we're going to be showing you much today that isn't already available, but keep that in mind. So first, thank you very much. It really is because of the support for Flow and the use of Flow and invocable actions that we have been able to grow the team, that we get to spend our days building this stuff, making it better. It's very exciting, and it's one of the most fun parts of Salesforce, really as a result of the work that the whole Ohana does with actions. So thank you very much. All right, so to ground this, of course, it's worth pointing out that Salesforce has an overabundance of actions. You're probably familiar with many of them. You might know about all of them. Some of you probably don't know about invocable actions. They're the ones here on the right, the ones that you see when you go into Flow Builder or Bot Builder or the new Copilot Builder and say, I want to create an action here. So they're different from the quick actions and the platform actions and a lot of the older technology. What defines an invocable action and really makes it what it is? The first thing is, at least as far as this room is concerned, it's Apex. It's an Apex class. So if you're familiar with building and writing Apex, you can create an invocable action very easily. It's not the only way to build invocable actions. You can also build them with OAS specs. You can generate them through external services in that way, and internal developers create them often in Java. But today we're going to focus on the tool that most of us use, which is Apex. What you do with an Apex class that turns it into an action is you annotate it. You annotate that class, and one of the things that does is it defines the inputs and the outputs and the shape of your Apex code, and it brings it to the attention of these builder tools, Flow Builder and importantly, the new Copilot Builder. So these inputs, these outputs, this description, these general capabilities of this Apex class are declared when you code the class up, and they're designed, the intent is that at design time, when somebody is in that builder, could be you, oftentimes it is the person who built it is then using it, but a lot of times it's not. A lot of times it's someone who isn't a coder and is taking advantage of the low-code nature of these builder tools. And so they get to use it at design time and configure it. You configure it at design time. That means I'm in Flow Builder or I'm in Copilot, and I'm specifying the inputs that are going to be passed to that action. When is it going to be passed? It's going to be passed when the action actually executes at runtime. And invocable actions allow both literal values but also dynamic values, which is super powerful because that means that every time you run that particular code, you can have somebody passing in a different set of inputs. And then finally, whenever you take an Apex class and you make it into an invocable action, you immediately make it API accessible. Like it instantly gets an API of its own. You don't have to define any resources. You don't have to set anything up. Every invocable action is API accessible, which is quite a superpower. Let's talk about the benefits. Why would you potentially want to take a perfectly reasonable piece of Apex code and go through extra effort and turn it into an invocable action? The first one I'll talk about is the concept of building blocks. I love talking about code as building blocks because one of the biggest opportunities for developers as we move forward is empowering a large orbiting sphere of non-developers to use the code that you write. Typically, I would draw that on a diagram. I would show this ring of non-coders like admins, citizen builders. Today, we're starting to say, you know what, there's another set of participants, the co-pilots and the APIs. And so when you take your code and you turn it into an action, you're enabling Copilot as well as humans to make use of it. On the left, you see an example of some of the inputs to your code. On the right, this is how, if you're not familiar with it, in Flow Builder, a non-admin is going to see those inputs. So they have access without having to see your code, without having to have access to your code, without having to have any comfort or familiarity with code at all. They get to see the inputs that you've defined, the outputs that you've defined in a friendly way. That's what I mean by turning things into building blocks. The second big benefit of invocable actions is how they supercharge flow. Flow, as you may know, has seen explosive growth in the last 5 or 10 years because it's just an incredibly powerful tool set for doing more with your Salesforce investments. What invocable actions allow you to do is add powerful custom capabilities to your flows. This particular example is kind of a random example I picked from an old demo. And what you see here is a mix. You see a mix of all of the orange and the pink and the blue. Those are standard flow elements. That's just the stuff that we make available out of the box. Each of those 3 navy blue actions is taking some very domain-specific capability and making it available. In the upper left there, you've got an action called Load Massachusetts Disclosure. So that's an action that actually understands the domain of Massachusetts law, which is not something Salesforce is ever going to ship out of the box. And then you've got one on the far right, in the upper right-hand corner, that knows how to deal with SSNs. It knows how to match SSNs. Maybe it knows how to look up SSNs in a database. So whenever you take some of your code and you turn it into a building block, you're increasing the tool chest of your org's flow capabilities. And that's very potent. Third benefit, you can use in flows, in Copilot, you can tap into powerful aspects of Apex that you can't do anywhere else. Just picked a couple here as examples. In the upper left, Apex is pretty much unbeatable at handling collection processing. I want to loop through a bunch of records. I want to make some changes to it. I want to create a map. I want to do something with that map. You can do a lot of those operations in Flow, but you're never going to beat Apex for speed, for efficiency. And when you take some of that code, maybe it's just a few lines of code, you turn it into invocable action. Again, you're taking that power, you're making it available to every one of your flows, every one of your copilots. I've created invocable actions that are like 2 lines of code, but they're 2 really useful lines that you just can't do in Flow without them, and that is very powerful. Advanced SQL I'll mention. You can do some powerful queries in Flow using getRecords, but there are plenty, as you are probably aware of if you do a lot of SQL, there are plenty of more complex queries, nested queries, child queries that you can't do in Flow today. And honestly, I'm not sure when we're ever really going to make them available declaratively because just setting them up is difficult, right? If you're a non-admin, non-SQL developer, just setting those up can be a challenge. But if you take the code and put it into a domain-specific action, make that action available in Flow Builder, you can have the best of both worlds. Another benefit, you can just make your flows run more efficiently. On the left here, you see a typical flow that's got a couple of loops. Now, looping in Flow is very powerful, but some of you can attest that you can run out of headroom with data and loops in Flow. There's just some fundamental limitations there that are sort of part of a multi-tenant system. And what you'll find is if you take those same looping constructs and create invocable actions for your most important ones, for your the ones that you find yourself doing over and over again, you can make a given flow run 10 times faster. And because you've coded that up as an action, it becomes highly reusable. Eric's going to give you some examples. Another advantage is that you, with invocable actions, can take your Apex class and you can give it a custom user interface. And this is really cool because no matter what you do at the code level, if you want your non-coders to be able to use your code, you kind of have to solve a UI problem. Now, maybe you're perfectly happy building an LWC to do that, but we wanted to make it possible to package a custom UI with your Apex code. What you see here is the same action on the left as on the right. It's an action that Eric actually wrote to do some record processing. What you see on the left is the auto-generated input mapping that you get in Flow Builder, you get in Copilot Builder, regardless, so you don't have to do this. Everything I'm saying here about custom UIs is 100% optional. Hey guys, by the way, there's a lot of seats here, and like I'm not spitting or anything, so feel free to come up and enjoy. So we'll talk a little more in depth about how you actually add a CPE, a custom property editor, to an action. Another big benefit, the last one I'm going to focus on, arguably the most powerful, is that invocable actions are one of the best ways to connect Salesforce to non-Salesforce systems. Every one of your actions can have call-out logic in it, can use name credentials. On the left here, you see an action that I had built because I was not getting to meetings on time. Google Calendar, which is the standard inside of Salesforce, just doesn't ring loudly enough or frequently enough. I'm one of those people that needs an alarm that just hits you over and over again. So I actually solved that by building an Apex invocable action that calls the public Google Calendar API, and it does it like every 15 seconds in a flow. And I run that flow all day long in my home office. And let me tell you something, I found a really annoying sound for it to play when I'm late to a meeting. So that's just one example of how you can tap into the rich world of all the APIs that are out there and bring that functionality into Flow and now into Copilot Builder as well. The final thing I'll say before we start getting into some of the interesting details with Eric is I want to share a few numbers with you. One of the things that very few people know is how prevalent invocable actions are inside of Salesforce. And by that, I mean internal Salesforce Scrum teams on Sales Cloud, Industry Cloud, Service Cloud. They build invocable actions constantly. They're building them at a rate of about 10 a month now. And in the latest Salesforce release, there are actually more than 400 invocable actions that are available. You won't see all of those because a lot of them are behind perms. They're part of Health Cloud or they're part of Omnichannel or something like that. But there is a growing amount. So I love pointing that out because those are first-class Salesforce development teams. They don't have to use invocable actions. Most Salesforce code is not written as invocable actions, but they're increasingly choosing to wrap their functionality in these building blocks. Why are they doing it? Because their customers love the flexibility. They love being able to take Salesforce functions and pass in dynamic inputs at runtime instead of filing something on an ID exchange and hoping that Salesforce will add a bespoke way to change a setting. Give me an input. Let me make my own flow and pass my own value in that I get from somewhere else. So that's an important number. And then this other number that I'm real proud of is that we're at 6.8 million individual types of custom actions that have been created across all of Salesforce. And that really, that number kind of blows my mind. I had no idea that we were up past 5 million. So with that, I'm going to hand it over, and Eric's going to talk about how you actually build these.
Thank you, Alex. That's a great introduction. Appreciate it. So as we started out, invocable actions are really just Apex code, but there's a few things that you need to put into this Apex code to turn it into an invocable action. And the first thing is we annotate one of the methods in that Apex class with invocable method. And by using that annotation, that's what exposes that Apex code to systems like the Flow Builder. Then we also have our invocable variables. When you saw the list of attributes, that's where we define the inputs and the outputs that are going to be recognized and passed between your action and things like flow. Those inputs and outputs are organized into child classes because we're passing things in one group or one list at a time, and same thing coming back out, so we put them all together into a class. You can extend the Apex action with the exception handling standards that are built into Salesforce, and then the the core or the key part of the invocable action is your Apex code itself. What are you writing? What are you creating? What are you designing this action to do? So we look at these. Here's an example of an invocable action where we have the invocable method annotation, and there's just a few things we have there. We're giving it a name. That's the label that'll appear when somebody does a search in Flow Builder and tries to find this action. We can also give it an icon if you want to use something other than the standard little Apex symbol, so it looks a little different in the Flow Builder. You can specify that Lightning Web component you might have created for the configuration editor for this, and then as always, we try and have a description to have a little more information about it as well. The invocable variables, we set these up. This is where we define our inputs, we define our outputs. So they're both annotated with the invocable variable annotation. And in grouping those into child classes, one of the things this does is it makes it easier to handle the groups of the inputs and the outputs, because when the processing is happening behind the scenes in the system, is everything is bulkified. So you could have multiple requests coming into your action all in one transaction. So when you create these actions, you are setting them up, and you're actually setting them up to handle a list of requests and a list of outputs. You're just processing one at a time within your Apex code, but you have to keep in mind that this is being bulkified by Salesforce. It makes it more efficient, runs better behind the scenes, but you need to structure this action in such a way that you're supporting that design pattern. And as always, anytime you create Apex code, you want to make sure you have good code coverage, that you're exercising all of the things that the code should do, the things that it should not do. So you do want to have a good test class for your invocable action as well. And because this is Apex, we package it and provide it like any other Apex code. You can use first generation, second generation packaging. We do recommend second generation packaging. But one thing to keep in mind is once you deploy or release one of these actions into an org and somebody's starting to use it in a flow, you can't then go and delete that action because it's being referenced somewhere else in the system. So do keep that in mind. Now, there's a few ways, and we touched on this briefly earlier, how can you enhance that invocable action? I mean, you guys are the coders, you're creating something that's great, it's going to do what you want it to do, but you're also making it available for admins and other people to use. You want them to use your code, you want them to take advantage of it, you want to make it easy for them. One of the things you can do is you can give it a custom icon. When you put this action in the Flow Builder that doesn't have to look the same as all of the other ones, you can have a unique icon for your action. There's a couple ways you can do that. Salesforce has hundreds of icons available as part of the Lightning design system. And all you need to do is, in your invocable method, is just to reference one of those standard icons that's available. And that's the icon that'll be used when somebody's in the auto layout version. This doesn't work in the free form. In auto layout, in the Flow Builder, your action will have that icon that you reference. In fact, you could even do a custom icon. You can create your own. It doesn't have to be one of the Salesforce icons. And this is done with what's called an SVG file. It's a type of graphics file. And you can create any icon, image, logo that you want to have there. Now, there's a few things I found that I struggle with it a little bit. Other people do initially when they do this. It's a little tricky getting these SVG files to work correctly in there, but there's just a few things here. I won't read everything on the slide, but there's certain attributes that you have to have in that SVG file, and there's certain ones you have to avoid. So if you have a file that has a couple of these attributes, they're not going to work directly in the Flow Builder. And you have to have a color attribute defined for every path, every piece of that image. Now, these SVG graphics files, you might find another image that you want to use. It might be a JPEG, it might be a PNG file. Online, there's lots of free resources there that will convert existing images to an SVG file. And these files are stored as static resources, and they are packaged along with your action and released that same way. So take advantage of this as well if you want to really jazz up what you're creating for your actions. Now, the other thing that really can make your invocable action usable, have people want to use it, take advantage of it, is a custom property editor. Custom property editors allow you, the developer, to present those attributes and get that information in the fashion that you want it out there. What we see on the left is, by default, you'll get an alphabetical list of all of the input attributes that are defined in the action, and the user decides whether to include them or not and what the value is going to be when they pass it into it. Now, for somebody looking at that, it's going to be a little tricky without documentation or out ringing you up on the phone and saying, hey, what do I put in here, what do I put in there? It's not always an easy or an intuitive way of configuring that action, but with a custom property editor, you have full control over how you're presenting those requests for these inputs. You can even provide standard information. You can define your own pick list that somebody can select something from. You can, rather than having somebody having to remember API names of fields because they need to have a list of fields that the action might be acting on, you could have the property editor give them a list to choose from without them having to remember what the names are or to look those up. You can use conditional visibility. You could only show certain pieces of those attributes or certain components in this property editor if they make another selection. So you can have various ways to configure these components. Now, here's just an example of a simple property editor that I did for a component I wrote just to draws a line. But when the user is configuring this, they're doing things, they're trying to set the margins above and below that line. They're setting the width of the line. They're setting the color of the line. And if all they're doing is putting in the attributes, they're not going to know what it's going to look like until they see it and run the flow. But with a custom property editor, you can actually have it interact with the user while they're making these changes, and it'll show them exactly what it's going to look like when they embed this component wherever they're going to put it. And it makes it easier for you. I mean, it reduces your documentation burden and reduces some of the support overhead you have for components. So how do you build them? We're going to go over just some basics on this. There's a lot of detail there, but we did just want to go over what's involved in a custom property editor, what you may want to do. And I'm going to let Alex chat about that for a little bit, and then Ruben and I will come back and show you some more things.
So we're going to go by this material pretty quickly because we only have so much time, but this presentation will be available both in slide format, and I'm told this video will be available permanently as well, which will be nice. Okay, so building a CPE, the highlighted item here, that little configuration editor reference, that's what links your Apex class to the LWC that's going to get initialized in the property editor or flow builder when someone clicks on an instance of your Apex class. So once you have that, your basic job is to build an LWC that properly responds to context being passed by flow builder when it gets initialized, and kind of tracks what users are doing and passes flow builder back any user information that needs to be persisted when the flow gets saved. So the kinds of information, there's actually 5 different kinds of information that flow builder will pass you as context. And this includes information like, hey, in some previous session, perhaps in this flow, someone may have provided some values at design time, filled in some numbers for some inputs. You're going to need to recreate that into the CPE so they see the numbers that they set the last time they were there. And basically, all of the context you need is available there. When users interact with your CPE in the property editor, you need to pass that back to Flow Builder. The main reason is that Flow Builder is going to handle all of your persistence for you. It is your database. So you don't have to worry about storing any values. If you constantly are passing back user changes, then whenever the flow gets saved, that's all permanently stored with the flow metadata. When the user comes back a week later and clicks again on that property editor, all those values are passed to you so you can recreate the appearance that they expect. There's a lot of optimized base components that have been built to make it easier to build custom property editors. One of the most important is Flow Combo Box. In dealing with actions, as you've picked up already, a lot of the lift is mapping some upstream output to the input of your action and making it possible for the outputs that your action generates to be used further down the flow in other actions. So there's a lot of this mapping. Well, in order for mapping to be easy, there's got to be a really smart pick list. And that pick list has to show all the resources that are going to be available at runtime. And that's what Flow Combo Box does. So you can drop that in. There's also support for validation. So when someone tries to leave your LWC, you can run some code. You can use this for what you'd expect. Hey, you didn't fill out this required field. You know what? The sum of the values that you've entered in those 3 fields needs to add up to at least 20. So you can stop them from exiting your property editor if you need to. So that gives you some sense of how you build an invocable action. One of the things we also wanted to share is some of the cool synergies you can achieve by using your invocable action with a couple recent Flow innovations that make it easier to do things natively in Flow, and how these can be put together to solve problems very effectively and really get your invocable action the complex data structures that it needs to be highly effective. So Ruben, why don't you tell us how that works?
Conversation with all of you, especially because we are really, really excited about all of the productivity that these invocable actions are going to unlock. And we really want to make sure that all of you as developers are able to leverage them with as much efficiency as possible. And in our conversations with you, one thing that we've heard is that data processing can be a little bit of a bottleneck sometimes, which is why 2 of the features that I wanted to talk to you about today are designed to address just that. Now, this is a pretty high-level view, and we're going to go closer to the trees in a second. But the 2 features that we're going to be discussing are transforms, which is a clicks, not code method of distilling or shaping the data that you have into the data that you want, which can be used either for data that's put into an invocable action, or can be used for data that's outputted by an invocable action. And the next area we're going to discuss is HTTP callouts, which allow you to obtain information via either GET or POST through the REST API. Now, I don't have to tell this audience anything about how to do that, because you're probably all familiar with Apex code that's perfectly capable of doing just that. But one big focus that we had was making sure that this was accessible to members of our organizations who might not be as familiar with Apex code, which is why on the right-hand side of your screen, left-hand side of your screen, right? Whichever one. Yeah, I'm not good with mirrors sometimes, but you can see the out-of-the-box Flow element for HTTP callouts, which is a way that you can now do a callout with clicks, not code. And the reason why this was a focus for us was because we wanted all of you to make sure that you're able to spend more of your time on the really hard problems that are affecting your organization and be able to delegate these types of tasks to more business-oriented users. But all the callouts in the world, whether you're doing them, whether an admin without Apex is doing them, Apex Experience is doing them, all of those callouts might not be that useful if you can't then use the data from those callouts in your invocable action. And the processing of that data once we've obtained it is really the focus of data transforms. The transform element was specifically designed to make sure that once you have the data that you needed to get, you are then able to extract the data that you want. This was really, really important. And I think a great use case to illustrate why is looking at something like a really complex list of data types that you then need to select a series of values from certain fields from in order to then be inputted to your invocable action. Right? If you have several values that you want to put into your invocable action, it can be relatively tedious or repetitive as developers to figure out exactly what that mapping looks like. But it can be downright daunting for people who don't have Apex experience. And we wanted to make sure that you are able to both delegate this type of work as far as that mapping goes to those without Apex experience, or if you're doing it yourself, making it less repetitive. And that's why we provide the opportunity to perform that mapping via a graphical user interface. This is an element that's in beta right now and will be released soon. And we're even more excited to announce that afterwards, we're going to be shipping things like a join opportunity, or a join functionality in this, which is analogous to a SQL join, and formulas for a mathematical relationship between an input and an output field. Now, we've talked a little bit about how to get the data. We've talked a little bit about what we're going to do once we have the data. I want to walk through an experience of what it looks like when we put those things together with an invocable action. What you're looking at right now is a record-triggered flow that is first using the HTTP callout in order to get data from Jira. And then after that, we're shaping that data, selecting the fields that we need with clicks, not code. So something that can be done by both a developer like us or maybe a member of our organization who doesn't have Apex background. And they are able to select which fields are appropriate for our invocable action, which then posts to Chatter. And what I really want to emphasize is not only is this exemplifying the capability of invocable actions, but also a lot of efficiency for people in this room. And speaking of efficiency, I'm really excited about all the time that we're hopefully going to save. I want to talk about some of the really advanced features that that time could be used for. So Eric, why don't you take it away with some really advanced actions that people can use invocable actions for?
Thank you, Ruben. I'm going to talk about one more way that you can extend your invocable actions. Basically, invocable actions are designed, they're meant to be a standalone element inside of your flow, in the flow builder. But what if you wanted to do that same functionality in that invocable action, but do it on a flow screen reactively while the user is interacting with the flow? This is especially important to me with a series of invocable actions out there that were developed to act upon collections of records, sorting, filtering, summarizing, a number of other things. These are all great actions that were standalone, but I wanted those actions to also be available to the users on a flow screen. So I came up with a way to turn any invocable action into a reactive screen component. So we could take a flow like we see right here that has a screen, it's getting input from the user, it's taking that input, it's passing that information to an invocable action. In this case, it's doing a summary calculation on a collection of records, and then it passes the result back. We have a second screen that displays the result. So we get input, we run our action, we display our output. But what if we could do that in a flow that looks like the one on the right? Single screen, reactive screen flow. And actually, we're going to try a live demo. So keep your fingers crossed. So here's that first flow. And I'm going to run it. And this is designed to display a series of records and asking the user to select some records, which I'm going to do. So I've got a data table, and I'm going to select a few records in that data table. And I'm going to say, I want to do a summary operation on it. I want you to, well, in this case, I could do a count, a max, a min, an average. So I want to do, in this case, let's do the sum. I've got a couple different numeric columns there. Let's pick the amount column. So give me the sum of the amount column for these three records that I selected out of the data table. So there's my input. I click next, the invocable action runs. It passes the output back to the flow. It says, here are the records you picked, and the sum of the amount column is 480,000. Great. Let's say I want to do a different calculation. I click next, we go back, and we start that whole process all over again. I say, well, maybe I wanted to include 2 more records here, but I wanted the average, same column, okay. We click next, and there's my answer. So we can rinse and repeat, keep going through this process, get our inputs, run our action, which is acting on the collection of records, and then displaying the answer. But let's do this exact same thing with that exact same invocable action, but we'll do it in a screen flow. And this is what it looks like for the user. We have the same inputs. We are going to go and select some records. We'll select the operation we want to perform. We'll do a sum. We'll do the amount column. And right there, I've got my answer on that same screen. The invocable action went out, did the calculations, came back, and presented that back to the flow. In fact, as I change my inputs, this is immediately reacting to what's happening on the screen. Let's change the column from the amount column to the probability column. Let's change from sum to the average. And so we can keep interacting with this component and it'll keep giving us a new value in real time. So how do we end up doing that? So to turn this invocable action into a reactive screen component, this is just a high-level diagram. As we see on the left, here's my flow. I've got 3 inputs. I've got a data table. I've got a couple pick list inputs. And then down at the bottom, I want to display my result. But my invocable action is sitting out on the cloud, waiting for some inputs and going to do its thing and pass back some outputs. How do I make these talk to each other and do it in real time? And to do that, I created a couple bridge components. And all these bridge components are designed to do is to talk to each other, take those inputs that the invocable action is looking for, pass it over to the invocable action, get the answer, pass it back to the flow. So I'm basically taking those connections, and so I have a Lightning Web component that basically is all it's set up to do is to get the inputs, pass back the outputs, but be reactive at the same time to all of those changes. And then I have a controller class that sits out there that it's designed to talk to the Lightning Web component and also invoke the invocable action. And then when it has an answer, it passes it back, and we have our output or our answer right on our flow screen at the same time. Now, I did this in such a way that here we take a look at the flow. This is the Lightning Web component on the flow and the flow builder. I have my data table, I have my pick lists, I have my new component, my bridge component. I'm taking my inputs, which is basically the same inputs the invocable action is looking for. And then I have my display text, which is waiting to react to the output of this Lightning Web component that I have on the screen. And that's where the magic comes in. So to summarize, we basically have a Lightning Web component and an Apex controller class that are talking to each other to allow the flow and the invocable action to communicate and do this in real time. And the real magic of this really is that the screen component is able to invoke an Apex class that is identified as Aura enabled. Apex can invoke an invocable action with invocable.action, and that's how these two are able to communicate with each other. Now, you could do away with that controller action and just put this Aura enabled and build that all in the invocable action, but I wanted to do this in such a way to take advantage of what you may have already created. Invocable actions that are already out there, why change them? Why modify them? Let's find a way to take advantage of them and put them to a second, give them a new life as a as a reactive screen component. So there's nothing really needs to be done to your invocable action, except for one thing. I did find that if I didn't have global scoping of some of my methods and variables, I didn't always get the results I wanted. So the only change I made to any of these invocable actions was to make sure that the methods and variables were global. The Lightning Web component is what exposes this to the flow screen. It's getting the same inputs that are going to be used by the invocable action, and it can do things like display error message if necessary, but it calls this controller that's out there and takes the results back, and it's also tracking any of these inputs reactively, so it can respond anytime something changes. And the Apex controller, again, is just taking, I got the same inputs and outputs that are expected by the invocable action. Hey, I got them from the Lightning Web component. I invoke by action with them. I pass the value back. And then because this is Apex, the controller piece, you want to have a test class that is going to give you your code coverage as well as exercise all of the features that might be in that action. Now, to make this easier for you, I don't expect you to be able to read what's on the screen here, but I created this as a template. And we have a resource link for you, and you'll be able to go right to the GitHub repository, look at my source code, and I've actually annotated it or commented it 2 different ways, really, depending on how you like to look at code and understand what it is. On the left, all of the comments are in line with the code. On the right, you can see another example where you just have the code, and all of the comments or descriptions of what it's doing is over in the margin. And these are also identified in that there are certain pieces of these templates that you leave alone. None of that code has to change. And then other things are commented there. Here's where you do your customization. Here's where you identify your inputs that you need in your action and the output coming from the action. So these are available as templates. You can take this design pattern that I've come up with here and apply it to any of your invocable actions that you may want to turn into a reactive screen component. So that concludes our presentation. Thank you very much. Please scan this QR link. We have a wealth of information here, a lot of documentation, source code links, other things, to everything that we covered today. You'll find the resources here on this link. So thank you for your time, and hope you have a great rest of your day. Thank you.